Oh, I'm sorry. Hey there, my Facebook pals. I was just reading up on Newton's third law of motion. In several of my comments about firing a rocket into space, some of my Facebook friends have said Newton's third law of motion explains in detail and flawless how a rocket gets propulsion in space. So, I had to go back and do a little studying on this third law of motion. And here's the way I understand it, and you let me know if I understand this right. You got an object, two objects, action, reaction, right? Action, reaction, right? Okay. You got an object, two objects, action, reaction. Okay. Do I have it about right that for every action there is an equal and opposite reaction? Is that about right? Okay. So I'm studying this third law of motion and it strikes me. What's the most important thing about this third law of motion? Is it for every action there is an equal and opposite reaction? No. The most important thing about Newton's third law of motion is that it takes at least two objects to get an equal and opposite reaction. So, in other words, if I am floating in space and my hand hits the ball, you're still going to get an equal and opposite reaction even in space. Okay? So it takes at least two objects to get an equal and opposite reaction. If there is no object, which, think about it, what is air? What is oxygen, helium, hydrogen, carbon dioxide? What is that? They're molecules, atoms, whatever, gases. And gases is an object, even though you can't feel it really, except for, it's an object. So, you have to have two objects to get an equal and opposite reaction, right? The rocket fires against the ground. It goes up in the air. The rocket firing against the atmosphere. The rocket goes out of the atmosphere. It fires its little jets trying to make course adjustments. But now, if space is a vacuum and there is nothing out there, not even an atmosphere, then there is nothing to get that equal and opposite reaction from. Sure, you're firing a force, but there is nothing to get an equal and opposite reaction from. So you cannot steer. And if you got that rocket into space, it will just keep going. Whatever trajectory it leaves the Earth at, it will continue on that trajectory and never stop unless it hits something, of course. So, you tell me, do I got it about right? For every action, there is an equal and opposite reaction. But in order to have an equal and opposite reaction, there has to be two objects. Okay, in this case, three objects. You got the fan, you got an atmosphere, and you got string. The fan blows the atmosphere, blows the string. Some cases you have many objects. Some cases you have only two objects. But some cases, like outer space, you have one object. Your ship. It fires against nothing. So you cannot get an equal and opposite reaction. So now, my physicist friends out there, you are extremely smart. I hand you that. Your mathematics are brilliant. And by the way, this is a dictionary. I just playing with you. Your mathematics are brilliant. You can look at a book and learn things that I can't force myself to do. You're much smarter than me. But you're smart. But you can be brilliant if you will learn how to open your mind along with the book. But if this is the only source of your knowledge, you can never be brilliant. You can only be smart. You can let your brilliance shine when you open your book and your mind, because that book does not carry all the answers. Your Newton's third law of motion works fine on Earth, but it does not work in zero atmosphere. This coming from a zero educated, some of y'all have called me a hillbilly, a hick. I'm just a guy who thinks a lot. Thank you.